So in the earlier lecture we have discussed about the classification and characterization of the optical fiber. When we were talking about the classification, it was basically characterized in on the basis of index profile. So the step index optical fiber, where the refractive index of the core remain constant and then abruptly change at the core cladding interface. And at the second point, the graded index optical fiber, the refractive index change gradually, and it basically maximum at the central axis of the core, and then it decreases gradually up to the core cladding interface. So that was graded index optical fiber. And further, on the basis of single mode and multi-mode, in graded index optical fiber only multi-mode was possible, so it is used as for multi-modes. So multi-mode graded index optical fiber, multi-mode step index optical fiber, and single mode step index optical fiber. This is the comparison of these optical fibers on the basis of their modes. This is multi-mode, single mode. This is the numerical aperture and the bandwidth only. So in case of multi-mode step index optical fiber, graded index optical fiber, and single mode step index optical fiber, you can see the numerical aperture. Numerical aperture is very small in case of single mode step index optical fiber, that is 0.08 to the 0.15, and then it is for the graded index optical fiber, the range of the numerical aperture is 0.2 to 0.3, and here for the step index it is 0.16 to 0.5. And then bandwidth. In case of multi-mode step index optical fiber, this is only 6 to 50 megahertz kilometer. In case of graded index optical fiber, it is 200 megahertz kilometer up to the 3 gigahertz kilometer, and here in single mode this is only 500 megahertz kilometer. So you can see that single mode step index optical fiber and multi-mode graded index optical fiber have large bandwidth as compared to the multi-mode step index optical fiber. In this particular case, the bandwidth is 6 megahertz kilometer to the 50 megahertz kilometer. And in case of multi-mode graded index optical fiber, you can see that is 3 gigahertz kilometer. So this we have already discussed, and now we will discuss about one more important parameter, that is called V number, normalized frequency. So this before we discuss about the normalized frequency, when we were characterize the optical fiber, we have mentioned that depends on the three vectors, three parameters. Those were: number one, the composition of the material, that indicates towards the refractive index of the core, and second was related to the nature of light, that means information about the wavelength of that particular color of that light which we are using, and the third was diameter of the core and length of the core. So all these basically three parameters are included into the V number. So V number is very important parameter for the designing of the optical fibers. So the next point is about the V number. and sometimes it is called the normalized frequency. So the title is V number in optical fiber. So you can write here that an optical fiber is characterized by one more important parameter, that is known as V number or normalized frequency, or sometimes it is known as normalized frequency. Of the fiber. This V number is defined by 2 pi a upon lambda into a square root of n1 square minus n2 square. So this of V number have all the information about the optical fiber. It includes the diameter of the core, that is 2a. It includes the wavelength of the light. This 2a is the diameter of the core. Diameter of the core. This lambda is the wavelength of light which we have used as an optical signal, and the numerical aperture, that means the refractive indices of the core and cladding. This numerical aperture in terms of the refractive indices. Right, N1 and N2. So because of this reason, this optical, V number is important. This normalized frequency parameter is important because of this reason. It includes all the information of the optical fiber, and this numerical aperture you can write in a different way, as you know that we have defined it earlier in terms of square root n1 square minus n2 square and the n1 square root 2 delta. So V number can be defined by using the numerical aperture formula in terms of n1 and n2 in terms of fractional refractive index delta. Delta is fractional refractive index. This delta is equal to n1 minus n2 upon n1. So the information, what information basically one can extract from the V number. So as in earlier case we have seen that single mode and multi-mode, step index optical fiber and graded index optical fiber. So suppose we have to find out the modes, number of modes in the optical fiber, whether that is step index optical fiber or graded index optical fiber. We want to know that how many modes are propagating into the optical fiber, right, through the core. So for that information this V number is important, and because here I am not just going into the derivation of that particular topic, so I am writing directly that the number of modes in step index optical fiber the maximum number of modes supported by a step index fiber is determined by N maximum is equal to V square upon 2. So if we know the V number, one can calculate the possible number of modes into that particular optical fiber. Here I have keep this number 2 in denominator, so it is basically for the step index optical fiber. And if I have to calculate it for graded index optical fiber, then it will be V square upon 4. When I am using alpha, the index profile parameter, basically that alpha is 2. So then it will be V square upon 4. So these are two formulae for the step index optical fiber and graded index optical fiber. For the step index optical fiber, it is V square upon 2, and for the graded index optical fiber, it is V square upon 4. So if this V number, which include the diameter of the core, wavelength and the information of refractive indices, is equal to or less than 2.405, then we say कि there is only single mode. If V is less than or equal to 2.405, we say there is only one mode, and that is optical fiber basically is single mode. But if V is greater than 2.405, then there will be multi-mode. That optical fiber basically will be of multi-mode. So how to determine the optical fiber will be single mode or multi-mode? Information basically comes through the V number. So if V is equal to or less than 2.405, that optical fiber carries single mode, and if V is greater than 2.405, that is the multi-mode optical fiber. So this is one of the important parameter to design the optical fiber, single mode or multi-mode, and to find we use it to find the modes in a particular optical fiber. So this was the basic idea about the V number. So from the V number, one can calculate the possible number of modes which basically travels through the core, and V include the diameter of the core, wavelength, operating wavelength, and the numerical aperture in terms of the refractive indices of the core and cladding. So this is the idea of a V number, that is sometimes called the normalized frequency. Thanks. If you have any problem related to any concept or any point which you have observed, you can message me downward of this video. Thanks for watching.